Today we're going to learn a lot of different features of how to describe graphs. So we're going to start with a concept that you've seen before called intercepts. So first we're going to look at x-intercepts. A function has an x-intercept if it crosses the x-axis, and this happens numerically when y equals 0. Your y-intercept happens if your graph or your function crosses the y-axis, and this occurs when x equals 0. And actually a whole lot of math boils down to finding our x-intercepts and y-intercepts graphically, which is what we're doing, and algebraically. So if I look at this first graph, then I have two x-intercepts. The first one isn't exactly at a integer, so I'm going to abbreviate that and say, let's say a half, or approximate rather, 1/2 0 and 3 0. So I want to emphasize that x-intercepts are points, so we're going to write that as a point, and then my y-intercept is the point 0 1. A word that might be new to you is relative maximum, relative minimum. So a relative maximum is a point that's higher than the points immediately to the left and right. And since we're talking about immediately, you can kind of think of it like cropping a picture. If I could crop a picture and make it look like a hill, that means it's a relative maximum. For a relative minimum, it's the same, but it's a point that's lower than the points to the immediate left and immediate right. So once again, can I crop the picture and make it look like a valley? So it's not about the overall picture. That's where sometimes instead of relative, you'll hear local. So there is something called an absolute max or absolute min, which means that you're comparing it to the entire graph. And so those are a little bit easier to spot. We pretty much focus on the relative. So if I look at my first graph here, I have one relative maximum in this graph. And I abbreviate that rel max at -1, 4. Maximums and minimums are points. I don't use the endpoints because they don't have any points to one side for me to consider it to be a maximum relative to those points. Then I have two relative minimums on that first graph of f of x. And these aren't exactly on my low grid line, so we're just approximating. So there's multiple correct answers as long as you're in the ballpark. So -4, -5, and the other one is 3, -4. So you'll notice, for instance, this point, you don't need to draw this part, this point is not lower than this point over here to the side, but if I just chop it off, crop it, and look just here at this picture, it's a minimum. It kind of looks like a parabola. A minimum right there. So a relative is just talking about relatives who are close to you. It's not talking about the whole picture. And another name for relative is local. All right. So looking at the next one, I have two rel maxes right here. So I have -2, 3 and +2, 3. And I have one relative minimum at 0 0. Once again, we're using the convention that the endpoints we aren't going to count as a max or a min if we're talking about relative. Okay? We've briefly mentioned these in class. We also have things called horizontal asymptotes and vertical asymptotes. So a horizontal asymptote is if the graph is approaching a certain y value as x goes to +infinity or -infinity. Okay, and the thing we'll talk about later this year is that horizontal asymptotes are possible to cross, and usually we don't, but you can, and the equation will be y equals a number. Vertical asymptotes are what happen when we're approaching an x value, but we don't cross that x value, and it looks like x equals a number. So looking at this first one, I want to emphasize it at first looks kind of like a square root, but it really is leveling off right here. You see how it's not getting much closer to 0? It's not looking like it's ever going to cross. So a square root function would continue growing. It doesn't have a horizontal asymptote, but I just wanted to point that out. That's not a square root graph right there, even though it looks a little bit like it. All right, so this would be the equation y equals 0. Or even you could argue y equals -1/2 or something like that. Pretty close to the x-axis though. This next graph has both a horizontal and a vertical. So here's my horizontal, y equals 0. And then my vertical would be about x equals -2. So what you kind of do is look at where the arrow's going. So those arrows, you have one going up and it's getting kind of close to an x value of -2, one going down getting close to an x value of -2 is how you find your asymptotes visually. This is one of the most important slides in all of Algebra 2. Yes, all of Algebra 2. And unfortunately, I am limited in my number of colors, so we're going to use your imagination. I know you have it. So the first thing we're going to do is talk about intervals that are positive and negative. And when we're talking about everything on this whole foldable, okay, everything on this foldable, we're talking about, my answers are talking about x values because the question has already dealt with the y values. So positive says for what x values are the y values positive. So y values are positive above the x-axis. So if you're into color coding, this is one color. I would do it pink, except for I don't have a pink marker. So I'm going to do this kind of faded red. All right. I have two sections in this that are positive. And I just forgot the most important part to start all of this. We're going to label all of our important points. All right. So this arrow is going left, so to -infinity, and down, so to -infinity. Then this point where it crosses the x-axis is the point -3, 0. Then I have the point 1, 4. That was a horrible 4. There we go. Then I have 0, 2. We'll just label our y-intercept, even though usually it doesn't matter for what I need. 1, 0. 3, -4, 5, 0. And then this arrow is going to the right, so that would be positive infinity, and it's going up. All right, so on a quick check, the first thing you would do is identify intercepts, so your x-intercepts, your y-intercept, and then relative extrema, so relative maximum, relative minimums. After you've identified those points, what are you going to do? By the way, infinities are never maxes or mins. After you do that, you're going to take this dramatic moment, and we're going to scribble out all the y values. Bye-bye. Bye-bye. No more y values. Okay? The y values are important for those points, but now the questions I'm going to ask are all dealing with where do I have certain qualities in terms of my x values. So, back to positive. Sorry. So positive is where it's above your x-axis. So I am above my x-axis between -3 and +1. That's where kind of this little loop right here starts at -3, ends at +1. So positive is going to be parentheses -3, comma, 1. And I have another interval here that I also need to notate, and that starts at 5 and goes to infinity. So union 5 to infinity. Notice all of these have parentheses. Everything for this foldable, positive, negative, increasing, decreasing, constant, all has to do with parentheses. Because at that x-intercept, my y value is 0, not positive. Okay, so now I'm going to do negative. Once again, I don't have orange. The next ones I'll be able to do in color. I don't have orange right now. So we're going to use our imagination and use this yellow color. Okay, so we have negative, means where are the y values negative, which are going to be these two pieces. So that's starting at negative infinity, going to negative 3. Union. Then I have a new piece right here that starts at 1 and goes all the way to 5. Union 1 to 5. Once again, everything has parentheses. All right, so that is positive and negative. You need 3 other colors for the next part. I'm going to now be able to do them in the color that I want to do them. And it looks like I, though, cannot... there we go. Can't erase all my color, but I can try to do a little bit, just so we don't get too messy. All right. So now we're going to talk about increasing, decreasing, and positive and negative. So first we'll look at increasing. Increasing means as I read, just like I read in English, from left to right, where's my graph going up from left to right? You can also think of this as slope. Where do I have a positive slope? And so I'm going to color it on here. Okay, those two green sections. So increasing is going to be from negative infinity to 1. Union, I have another piece, 3 to positive infinity. All right, and since I scribbled out my y values, I'm good to go. You're like, why is this confusing at all to people? Because if they don't erase their y values, then everyone wants to say it's increasing to that y value, which is 4. But since I scribbled it out, I'm not tempted to do that. Just a pro tip, take it or leave it. So decreasing means as I read from left to right, I'm going down. So my interval that it's going down is 1, 2, 3. Once again, these are going to be parentheses, just like positive, negative, because at that relative max, relative min, it's neither increasing or decreasing. So parentheses, 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 parentheses. All right, constant would look like if it was flat. So I'm just going to draw on the bottom of my graph. If it looks something like that, that would be constant. So increasing is talking about positive slope. Decreasing is talking about negative slope. The other two flaps, we'll talk about something called end behavior in class. So leave those blank for right now.